Okay, first here's the answers from the homework from Friday. If we need to go over any, we can. Some of them are kind of crazy. But I mean, we can go over them tomorrow, just real quick at the beginning of class. I'll give you like 5 minutes for questions. But nothing will be at this level yet on your quiz, but you should understand these. Because these are more like test-like problems, a little harder. There's the quiz ones. Number 4 was really hard. If you didn't get that one, I'm not worried about it. It was really hard to do without a calculator, I should say. With a calculator, it was pretty easy. But it did have a gray circle, so yeah, there's all those. If you're not done, you can pause it. Moving on to 2.3. I'll start this next section here. It's continuity. It's a pretty simple idea. Just talking about functions and if they're continuous or not. And I recommend, this is good reading right here, this big old paragraph right at the beginning. I'm not going to read it to you on this video because that's boring and pointless, but it's good stuff. Basically it says people used to assume that all functions were continuous, but then once we discovered that they weren't, we were able to invent cool stuff like lasers. All continuity is just like here, this is a continuous function because it's a nice smooth line. Basically I can draw it without lifting my pen up off the paper. This is not continuous because right here, oh, it jumps. And then right here, oh, there's a hole. And it jumps up there. And then that's all continuity is, basically. Just real, like, a 2-second explanation. If you can draw it without lifting your pencil up, it's continuous. If you have to lift your pencil up, it's not continuous. So like right here, this one is not continuous at x equals 1 because there's a gap, there's a jump there. And it's also not continuous at 2 because that point's up there. But at every other point, it's continuous, including the endpoints. The actual formal definition says that if the limit, like here if we're at 0, if the limit as x approaches 0 from the right equals the value of the function at x equals 0, which in this case it does, then it's continuous. It's defined as continuous at the endpoints if that happens. The only way that wouldn't happen would be like if you had an endpoint that had an open circle and a jump. I mean, but that's pretty obvious to see. That would not be continuous at that endpoint. So that's really all. I mean, this is like math ways of saying all that stuff. I don't want to complicate it too much. Next page gives some examples. This is a continuous function right here. Just y equals looks like x plus 1 or something like that. Just continuous, nice, smooth, nothing wrong. Here, not continuous because there's a hole in it. The next one, also not continuous because there's a hole and there's another point up there. Either way, it's not continuous. That's not continuous, obviously, because it jumps. If there's a vertical asymptote, like on this one, that's not continuous. And this one's crazy, but yeah, not continuous either because there's that weird part in there. These first three have what are, or not first three, but these two have what are called removable discontinuities, meaning we can take the function and do something to it to fill that in, basically. But we'll do that tomorrow. We'll worry about removable stuff tomorrow. And we'll actually do most of this stuff tomorrow. Yeah, you can almost just do your homework just off that. I'm going to give you some, like in 1 through 10, it says find the points of continuity and the points of discontinuity and identify each type of discontinuity. Well, you're not really going to do that, identify each type part. You're just going to do, like I'll do number 3. It says y equals 1 over x squared plus 1. Notice you can use your calculator on these ones. So if you're just trying to identify where that's continuous, easiest way to do that is look at the graph. I could do this one without. This is a bad example. my good old classic bad example, but we'll do it anyway. 1 over x squared plus 1. Pretty sure this is going to be continuous everywhere. The only reason this would not be continuous is if I got 0 on the bottom. That's why I said this is a bad example. But the only way I'm going to get 0 on the bottom is if that's -1. Well, that can't be -1 because it's squared, so this should be continuous everywhere. Let's check. I don't know what my scale is here. Go zoom 6. Yeah, pretty sure it's going to go on forever. Right? I don't know why it would stop. We'll start at the table and go by tens. Yeah, it just gets really, really small. So we could say, hey, the limit as x approaches, a little review from last section, the limit as x approaches infinity is 0, which means I must have a horizontal asymptote at 0. That's last section. This section is just saying, is it continuous? Yeah, it's continuous. There's no jumps, there's no gaps. This would be, you would say, it's continuous. I spelled that wrong. For all real numbers. I mean, there's no discontinuities. Let's see. Let's do one that does have a discontinuity. Like number 2. Y equals x plus 1 over x squared minus 4x plus 3. So again, you can just graph it, but I can tell you how to do it without the calculator. Your discontinuities for a rational function like this are going to exist where the bottom is equal to 0. So in that bottom, let's see if I factor that, it's x minus 3 times x minus 1. So I'll probably have discontinuities at 3 and at 1, because those are the numbers that will make the bottom 0. Let's check the graph. Let's see, on top I got x plus 1 over graph it. Looks a little weird. Looks like once I go past 0 and go into the negatives, that almost like there's nothing there. I'd be willing to bet it's just approaching 0, but let's check. If you ever see something like that and you're not sure, check your table. So I'll start my table as 0 and go by like 1s. And if I go to the negatives, yeah, it looks like it's just approaching 0, so I'm good there. So that means, whoops, where's my graph? It's continuous all through here and up to there, and then boom, right here at x equals 1, as we predicted. And if I look at my table at right at when x equals 1, I should say error. Yep. And at x equals 3 also, there's an error, because those are where my discontinuities are, which in this case are vertical asymptotes. There's not holes. There could be holes in some of these, but that's mostly in piecewise functions. These ones are vertical asymptotes. So your answer, it's continuous everywhere, but we'll just say discontinuous. How do you spell that? Tenuous at x equals 3 and x equals 1. This one you could identify the type of discontinuity. In this case it would be vertical asymptotes. That's what we have there. So that's all you gotta do for those ones. Find the discontinuities. I mean, pretty simple. Next I'm going to have you working on 11 through 16, and it's just going to be using this graph to answer these questions. So I guess like 11, does f of -1 exist? You just look when x is -1, is there anything there? You know? And then it's just asking you about limits. Do these limits exist? You should be able to answer all of those questions just based on what we've done before. And we can bring it home with the continuity stuff tomorrow. So go ahead and look at those. Do 2.3. Numbers 1, 4, 10, 11, and 13 through 16. Oh, wait, I just thought of something. Yeah. Can't do 15 and 16 yet. That involves removing the discontinuity, which I don't want to do yet until I'm actually there. So just 13 and 14, because 15 and 16, like I said, are removing discontinuities, which is, it's pretty simple, but it's just best explained in person. That way I can see when your faces look confused. So that's that. Tomorrow, first 5 minutes, you can ask questions. Next 10 minutes, you're going to have a quiz on 2.2. But, you know, as I saw Friday, no one had any questions or anything, and those that did got them answered. So, looks like we should be good to go. If you want more practice on that, your quiz level will look like numbers like 17, or 7, 15, 27, 39, and 43. I tried to pick ones you haven't done yet, and I tried to pick odds so that you could try them and check your answer. So, if you can do those, you'll be good to go on your 10-minute quiz tomorrow. So, you should try those, and enjoy your last 35 minutes of class working on this stuff. If you're not getting the answers on those, work together, talk to each other, get it figured out, because I'm only going to give you 5 minutes tomorrow to ask me questions. And that's all I have to say about that. See you tomorrow.